Welcome back. Now we're looking at a white scene with a black object inside of it because this gun has a mesh that's participating in the custom depth buffer. And in our post-process material called PP highlight, we're getting that custom depth information and we're plugging it into emissive color, which is applying this material to the whole scene. Now in this video, we're going to see about finding out which pixels are on the border of a given object. Now to sample surrounding pixels, we need something called the scene texel size. Right click and type scene texel and you'll see scene texel size. What exactly is a texel anyway? Well, our scene has a bunch of different materials inside of it, and each material has a different number of pixels per unit area. Texels are containers for pixels. Since each texture has a varying pixel density, we need a uniform size for pixels over the entire screen, and we can get this from the scene texel size node. That's why we need this. Now, for any given pixel, we can get its screen position using the screen position node. Right-click and type screen position. This returns the screen position for a given pixel. Now, just like the scene texture node, this is like a for loop that loops over the entire screen. And so whatever we plug into our PP highlight node is applied to every single pixel that's rendered to the screen in our scene. Now, screen position returns a 2D value. Now, instead of X and Y, for the screen coordinates, we call them U and V instead. So let's look at our viewport here. At the very top left of the screen, the UV coordinates are 0. Now, as we move toward the right, the U coordinate is increasing. It's kind of like the x-axis. And as we move down the screen, the V coordinate is increasing. It's kind of like the y-axis, only it goes down. Now, for our scene texel size, we can get the horizontal and vertical texel dimensions by masking for R and G respectively. So if we drag off of this and type mask, select component mask, and in the details panel for this mask, uncheck G so we get the R channel. Now copy this with Control C and Control V to make a copy. Drag off of scene texel size and plug into this other mask. And for this mask, uncheck the R and check the G. These values represent the size of the U and V of our texel. So let's make a comment for the R mask, hitting the C key, and type U, and in parentheses, horizontal. This is the horizontal dimensions for the texel. Take our mask G and comment this and say V, and in parentheses, vertical. This is the vertical dimensions for the texel. So we can go ahead and highlight these and bring them over here. So when I say texel, you can think of that as a pixel on the screen. Now, screen position is giving us the position on the screen in UV coordinates for a given texel. Now, in order to get the texel to the right of the current texel, we can use the U value from our scene texel size. Viewport UV, the return value from screen position, is a 2D vector, a U and a V value. And we want to add to that U value. So let's take this U value here, drag off of it, and we can use an append vector node. What this does is it essentially takes this single value and it's like making a 2D vector. If we leave the input for the B parameter blank, then the return value for this will be a two-dimensional vector where the first component will be what goes into A and the second component will be what goes into B, which there's nothing going in, so it'll be 0. Now if we add this to the return value from viewport UV, then we'll get the value of viewport UV with the texel U size added to its U component. So drag off of viewport UV and type add, and this gives us an add node, which will allow us to add two vectors together. Drag off the result of the append, and this add node now contains the screen position for the texel to the right of the current texel. So I'm going to highlight this and hit C and comment this to say right texel. Now we can use a similar method to get the texel to the left of the current texel. We can do this by taking our u and v values and getting the negative of those values by multiplying by -1. For example, if we want negative u, let's drag off of our mask and type multiply. And we can multiply by -1. Let's hold down the 1 key and click and plug this in. And for this value, in the details panel, give it a value of -1. Now highlight this and comment it and say -u in parentheses horizontal. And this gives us the negative value of our scene texel size in the u dimension. We can do the same thing for verticals. So select these two nodes, copy them and paste them below the V, plug the output for the V mask into this multiply node, and now we have -v in the vertical dimension. So this append node returns a 2D vector. Let's give this a comment so we know exactly what this returns. What it returns is the vector with the value u, 0. Now we can use a similar method to get the left texel, the texel to the left of the current texel. We can do that by creating another append node. And for this, we're going to use -u for the A and leave the B blank. And this creates essentially a vector with components -u, 0. Now, if we right click and get screen position again, then we can take the return value for viewport UV and use an add node and add -u, 0 to that, and this will give us the left texel. Basically, it's the current texel plus the vector with -u in the u component, and that gives us the texel to the left. So comment this and say left texel. Now we can do the same thing to get the upper and lower texels as well. See if you can pause the video and give this a try, and then we'll do it together. Okay, so let's get the upper texel. So we're going to take the V value and we're going to use an append node, so append vector. And for this one, we want the A component to be 0, that's the U of the vector, and we want the B component to be the value of V. So I'm going to comment this and say that this is the vector 0, V. And I'm going to go ahead and create another append vector here, and this one will have -v for the B component. And I'm going to give this one a comment 0, -v. Now, since the V axis starts at 0 at the top and works its way down as V values increase, then if we take our screen position node and we use add, and we add this 0v vector to it, then the result is going to be the texel below the current texel. So I'm going to comment this and say bottom texel. Now finally, if we come down here and use screen position and use an add node, then plug in 0, -v, then this is going to result in the texel above the current texel. So I'm going to comment this and say top texel. So now we have the left, right, bottom, and top texels. In other words, the texels above, below, to the right, and to the left of the current one. Now remember, texels can be thought of as pixels on the screen. It's a bit of a simplification, but for our purposes, you can think of it that way. So I think this is enough for this lesson. In the next lesson, we're going to continue with this so that we can get closer to having our outline effect. So see you in the next video.